Welcome back again. All right, so in this video, we are going to talk about one of the functions or the uses of what dimensional what analysis. All right, so the part that we are going to talk about is deriving a formula. Deriving a formula. Deriving a formula. So what are we saying here? We are saying that we can use dimensional analysis to do what? To derive a formula. Assuming the period t of of a simple pendulum depends depends on the length L and acceleration due to gravity g. Use dimensional analysis to find the relation right. Okay, so we can use dimensional analysis to derive a relation here and a formula here, right? So we're saying that assuming the period t, so the period t is, it depends on the length L. So it is proportional to length what? L, right? And acceleration due to gravity g. Now, in this case, this L and t, to be able to use dimensional analysis, let's say we don't know any, we don't know the powers of this L and what t. So let's say we represent with what x and what y, right? So at this point, to remove this proportionality sign, we need to introduce what? A constant. So this is going to give us t equals k l x g y. So what happens here? We now want to introduce the concept of dimensions, right? T here is talking about what? Time. Then k is a constant, L is what? The length, and g is acceleration. So let's see. So the dimension of t will be equal to the dimension of this constant. So we get rid of that. So that will be the dimension of L exponent x, the dimension of g exponent what? Y. Okay. So let's see. What is the dimension of what? T. It happens to be what? Capital T. Dimension of L, which happens to be the length, right? So we still have L exponent x. What about acceleration due to gravity? That is L t negative 2, or exponent what? Y. At this point, t equals, we have L, expanding this, multiplying L exponent y, t exponent negative 2y. So t will be equal to, you see, we have L here, right? So what happens here? L is here. So we have our L plus, so 1 plus Y, then T, T, so this is X, sorry. So you have X plus Y, then T exponent negative 2Y, right? So let me write it again. T equals L exponent X plus Y, then you have T exponent negative 2Y, right? So what next? So comparing exponents from both sides of the equal sign, you know that at this point we have L exponent 0, which is the same as 1. So there's no need writing that. So it means that when I compare the L side, I'll get 0 equals X plus Y as 1. Then the T, I have 1 equals what? Negative 2Y. From here, I can easily get my what? My Y, the value of what? Y. So let's see what happens. We have Y being equal to negative 1 on what? 2. So if Y is negative 1 on 2, then from here, 0 equals X plus Y. Then 0 will go to X minus 1 on 2. Then X will be what? X will be equal to 1 on what? 2. So at this point, from the relation, we know X and Y now. So we can easily write it as T equals K without a dimension. So the K is back. K. So from here, we're taking it from here. The dimensional analysis helped us to find the values of this exponent here. So at this point, we can write it here. Our this is now, so that was X. Then X is 1 on 2. Then we have the G exponent negative 1 on what? 2. Now, this can be written as K root of L divided by, this is inverse, right? So you can write as root of what? G. And if I have root of X on root of Y, it is the same as the root of X on what? Y. So I can easily write this as A T equals K root of L on what? G. So that is the relation using this dimensional analysis, right? So that is that. You can try similar questions on this concept. All right. Thank you for watching.